Hello everyone, today is day 55 of solving a LeetCode problem every day, and today I'm going to be solving search a 2D matrix. So you're given an m times n integer matrix with the following two properties. Each row is sorted in non-decreasing order, and the first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in matrix or false otherwise. You must write a solution in O of log n m times n. So basically, the solution is giving us a matrix and is asking us to solve this problem in O of log m times n. So that's pretty much what this is telling us is that we're going to perform some type of modified binary search on the matrix, and we can find out whether or not the target is within the matrix. So I mean, the second thing that's telling us that we're going to have to use binary search is the fact that each row is sorted in non-decreasing order, and the first integer of each row is greater than the last integer of the previous row. So essentially, if we just look at this matrix as a flattened 1D array, then we can just perform binary search on it and solve the problem this way. And basically that's essentially what we're gonna do. So first we're gonna find the number of rows and columns. And we can find the number of rows by the length of the matrix and the number of columns by the length of the first row in the matrix. And then what we're gonna do is get our right and left pointers. So our left pointer is just gonna be 0 since that's the first index. Then our right pointer is going to be rows times columns minus 1. And the reason we're subtracting 1 is because this is 0 indexed. And rows times columns gives us the total numbers in the matrix. And now we're just going to pretty much perform like our modified binary search. So while left is less than right, we're going to calculate the midpoints. So it's going to be left plus right minus left. And then we got to perform floor division by 2. And then what we're going to do is also calculate the row and column for that midpoint. So we can calculate column by performing the floor division by the columns. And then we can calculate the row, or sorry, I got that backwards. We can calculate the row by performing floor division with the midpoint and columns, but we can calculate the number of columns by performing the remainder operator, so the modulus operator. And then so the rest of it is just binary search, so we can check if it's less than target, and if it is, we increment our left pointer, and if it's greater than target, then we can decrement our right pointer. And basically, so we set it to the midpoint, we subtract it by 1, so we don't process the midpoint anymore. And we do the same thing here. We add 1, so we don't process that midpoint anymore. Then otherwise, if none of these cases are true, that means that we found the target, and we can return true in that case. And we can just return false once we're outside the loop. So if I run this, so it seems like we've gotten an error. So let's see. So true was given here, but we gave true here again. So what is the problem here? Let's see. So it's outputting true both times. Let me try printing this midpoint and seeing what's happening. Let's actually put this here. So let me print this midpoint. Okay, so 5. So if we do 0, 1, 2, 3, 4, 5, why is this happening? So let's also print row and column, and let's see what was outputted for that. Okay, so we have 1 and 1, and is that correct? So our midpoint is 5, so we have 0, 1, 2, 3, 4, 5, and so that is 1 and 1, that is correct. And then we see that our target is 13, so it's less than target. So in that case, we're incrementing our left pointer. So let's see if we get here. Okay, so we do get here. Okay, so it's because this needs to be elif. So if I run this again, cool, and submit this, great, so that worked now. So the time complexity of this is gonna be O of log n times m, and the reason why is because we're gonna process every single element, or not every single element, but since there's m times n elements in this matrix, that's the total elements that exist. And then it's going to be the log of that, since we're performing binary search and we're pretty much like exponentially decreasing the amount of elements we have to process each time. So yeah, that's my solution for the day.